Hi, I'm Bridger Herman, a PhD student at the University of Minnesota studying computer science. For this portion of the tutorial, we'll be talking about the visualization design interface for the artifact-based rendering technique. First, I'll talk a little bit about the artistic metaphors we employ in the user interface, and then we'll dive into how to use it. When we built this user interface for visualization design, we were looking for a metaphor to translate the inherently technical computer graphics process for 3D visualization into something that aligns better with artists' creative processes. The metaphor we ultimately chose was intaglio printmaking, where many plates are inked and pulled through a printing press in order to create the final image. This is quite conceptually similar to the 3D computer graphics-based visualization process in which layers like glyphs, lines, and surfaces are composited together in order to make the final visualization. In the design interface, we use this metaphor in two ways: key data and data impressions. Key data are the geometric representations of your data, points, lines, or surfaces, and can be loaded from VTK unstructured grid files. Each piece of key data has scalar and vector variables associated with it. These key data are dragged into what we call data impressions, or layers, in the visualization. We can then apply variables and visual elements to each data impression as we see fit. All of the data impressions in the center panel are composited together in real time to make the final visualization. Let's now move into a few demos of the user interface to show its capabilities. Here, we can see the three-part design interface. On the right, we have the design palette. On the left, we have the data palette. And in the center, we have the composition panel where it all comes together into a visualization. Starting in the upper right, we have the plates, which represent the algorithms built by the programmers of the artifact-based rendering engine. Below that are the visual elements that the artist has imported from the Sculpting Viz library or their personal collections. These include color maps, glyphs, lines, and patterns. On the other side, we have key data and variables. Data and visuals are placed into data impressions in the composition panel to make the visualization. Let's walk through making a simple change to this visualization. So far, we have the Gulf of Mexico ocean floor with a color map applied to elevation, and a glyph layer that shows chlorophyll and salinity. The more chlorophyll, the denser the glyphs. So now let's say we wanted to replace the salinity variable with temperature instead. All we need to do is go over to the data palette and drag the temperature scalar variable over into this data impression, and the visualization will update accordingly. We can also double-click on the color map, and it will bring up a color map editor that allows us to create custom color maps based on the data values. Now, let's build a multivariate visualization from scratch, walking through the entire process from loading data to making visual changes to viewing the output. Let's first navigate to the design user interface in a modern web browser. I'm using Firefox. The specific URL for each breakout session of the tutorial will be provided later today, but since I'm running the ABR engine locally, I'll enter localhost:8000. We now see the ABR design user interface. We can start by either loading data or visual elements. Let's start with data. I've preloaded a dataset from the Filchner-Ronne ice shelf in the Antarctic that contains surfaces for the land ice and bathymetry, some streamlines for the ocean currents under the ice sheet, and glyph samplings for 4 water masses. Key data can be loaded by clicking the Load Key Data button in the upper right. I'll go ahead and add all of these key data pieces to our data palette. We can see them show up in our data palette as we select them here. Next, I'll want to import some visual elements from the Sculpting Viz library. I can open up the library here. This shows me the artifacts that have been curated by the Sculpting Viz team. I can drag and drop artifacts from the dialog here into the user interface. I can come back and get more artifacts at any time. Now that we have our visual elements and data, we can begin building the visualization. Let's open up a visualization viewer so we can see our work. The first step is to make a new data impression by dragging a surface plate into the composition panel from the plate list. You can choose what to do next. I'm going to apply some key data, but keep in mind that you can apply visual styles first if you'd like. You just won't be able to see anything until you apply key data, since these are the spatial registration. I'm going to go ahead and apply the terrain key data first. So notice how this puzzle piece fits right in to that. Notice how the data shows up with a default white color map. I'm going to filter the variables for those that are available for the Antarctic terrain, and we just have elevation. So notice how this highlights blue. That means that we can drag and drop that here. Nothing happens yet because we haven't applied a color map. Let's go ahead and do that. This one looks like a nice ice color map. Go ahead and put that in the color map slot. Now is a good time to save the state. So let's click this double bookmark icon to save the state as a new name. I will call this Ronnie-Demo1. And hit enter, and notice how our state name changes here. I can save over Ronnie1 at any time by hitting the bookmark icon. I'll now follow a similar process for creating the bathymetry. Now that I've got a draft of these two layers, I can collapse them and move them to save screen space. Next, I'd like to introduce some glyphs of the water masses to our visualization. Let's make a new data impression for the high salinity ice shelf water. First thing we notice is that, oh my, those glyphs are huge. Let's reduce their size. Next, let's apply a glyph from the design palette. Now, let's apply the temperature variable and an orange color map. I'm going to zoom in a bit to get a better view of these glyphs. Now, I'm going to edit this color map so that we can see the data a little bit better. So now we see the histogram of our temperature variable here. I'm going to go ahead and flip the color map around. And now I'm going to move our color stops here so that it fits the data range better. Now we can start to see much more variation in the visualization. I will now repeat this process for multiple glyph layers. After working on this for a while longer, we can make the streamlines by dragging a ribbon plate into the composition panel. We can apply the streamlines key data we can apply the eddy direction scalar variable we can apply a blue-green color map and we can apply a line texture. We may want to change some additional properties, like the line width, and the orientation of the ribbon. If we want to share this state with others, we can go to the Load State dialog and click the Download State button. We can also save high-resolution screenshots by going up to the camera icon here and clicking it, which will save the current view as a screenshot. Screenshots can be saved by going to the gallery icon in the upper right-hand corner and clicking on the thumbnail for a state. We've now seen how to create a visualization from scratch using the AVR design user interface, which leverages artistic metaphor and language to better align the visualization design process with artists' creative methodologies. By building the interface on top of the artifact-based rendering engine, the result also allows artists to bring color, line, texture, and form from their existing art practices to the world of data-intensive science.